Hello everyone, welcome to tutorial number 5 in database CSEN 501. In the previous tutorial, we have seen how to map the EERD diagram into the relational schema. So in this tutorial, we are going to deal with the tables or the relations in the database. Actually, we are going to know something called query. What is a query? Okay, simply the query is a question about the data in the database. Simply, it's a statement requesting a retrieval of certain information from the database. So now we have relations or tables, and we have data inside this relation. And what we want now is how to retrieve this data and how to ask a certain question about the data in the database and how to retrieve an output. The question about the data in the database is called a query. Okay, to know how to deal with the query, we need to know the query languages that we are going to take in this semester. We have two languages, the procedural language and the declarative language. The procedural language, user tells the system how to manipulate the data. So it's not about just asking about certain information. However, in this case, the user tells the system how to get this data, how to retrieve this data. So here we are considering the how, okay, of manipulating the data itself. Another type of the query language is the declarative language, and in this type of language, the user states what data is needed, but not how to locate it. So all we care about in the declarative is to state which data or what data is needed, but we do not state how to manipulate or how to locate this data. Declarative language is like the SQL, which you will take in this semester, and the procedural language is like the relational algebra, which will be our focus in this tutorial. So what is the relational algebra? It's a procedural language that consists of 6 operations. It takes a relation or set of relations as input and produce a relation as output. So the input is always relation or in a type of relation, and the output is the type of relation as well. What are the 6 operations that we are going to deal with in relational algebra? First, the projection. What is the projection? The projection is simply to select a vertical position from the table. Okay, so the first operation is projection. Second one is selection, and in selection we deal with a row or tuple from the table. So it's a extraction of a horizontal part of the table. Union, difference, product, and renaming. These are the basic operations. However, using these basic operations, we can make another operations such as intersection, join, and division. Let's take an example in each type of this operation. Okay, the projection, the symbol of the projection is this one, which means that we are going to project column A from relation R. Let's take an example. Assume that we have a relation called student with ID, name, email, and this relation called student. We have two tuples, for example, ID1, ID2. What if we want to extract the IDs of all students? We want to get a vertical part from this relation. How can we do this using relational algebra? Simply, we can project the column we want. So we can write project ID and the name of the relation, which is student. So the input is a relation and the output will be a relation as well, which will be the ID. Okay? This is the projection. So the projection, in the projection we care about extracting a vertical position or a column from the relation. The second operation is the selection. And in the selection, we care about extracting some rows or tuples of the relation that satisfy condition C. Let's take an example. Assume that we have a table called student, ID, name, GPA. 1, 2, Ali, Ahmed, GPA 1, GPA 2. Let's assume that we have another tuple here, Ali, GPA 3. What if we want to extract from this relation all the students who has Ali as a name? In this case, we want to extract two tuples, this one and this one. Okay, so we can do this by the selection operation. Select from relation student. And what is the condition we want? Is name equals to Ali. So here we will write name equal Ali. So in this case, we are going to extract all the rows in students that satisfy this condition. Okay, let's take another example. Assume that we want to extract all the students whose GPA is greater than 1. So in this case, we want to extract this one and this one. So we can write extract GPA greater than 1 from student. In this case, the output will be this row and this row. What if we want to extract or to get the IDs only, not the whole row? So in this case, after extracting the whole row, we can project on the ID. So this query will get us the two rows of the students who has GPA greater than 1, which are these two tuples. Afterwards, we want to get only the ID, not the whole row. So we are going to project on this relation, which is the output from this one, and get the IDs only, which will be 2 and 3. Okay, let's move to the other operations, which are the set operation. The union, the difference, selection, difference in intersection, and the product. Okay, when we say union, we mean that we want to return all the tuples that are either in S or in T or in both. Okay, the union in relational algebra, when we say union, we donated it like that, which means that we want the tuples in R as well as the tuples in S. Okay? However, in this case, in relational algebra, the duplicates are eliminated. Okay? But not in all cases a union can be done between two relations. Why? Let's assume that we have two relations ID name, student, ID name, employee. And we want to get all the tuples in this relation with all the tuples in this relation. So at the end, we want a new relation with all the tuples in both of them. Okay? In order to know whether a union can be done in this case or not, we need to check the compatibility between these two relations. So we need to check whether the relations are union compatible or not. How to check that? First, we need to check if they have the same number of fields. So in this case, the student has two fields, ID and name, and the employee has ID and name. If one of them, for example, has another field, for example here a GPA, so this will have 3 attributes and this has 2. In this case, these two relations are not union compatible and a union cannot be done. So in order for two relations to be union compatible, they should have the same arity or the same number of fields. Okay? Student and employee in this case are having the same number of fields. Let's check the second condition. Corresponding fields have the same domain, same type. So for example here, we have ID, name, and here we have ID and name. If ID here is of type int, for example, and here string, then these two relations are not compatible. In order to be compatible, the type of the corresponding fields should be the same. So if here the type is int, this should have a type int as well. If this has a type string, then this should have the type string as well. So the two conditions in order to make sure that the relations are compatible is each relation had the same number of fields and the corresponding fields have the same domain. In this case, the relations will be compatible and a union can be done between these two relations. Okay? The union compatibility should be checked in 3 cases. Union, in case of the union, in case of the intersection, and in case of the difference. So the union simply get all the tuples that are either in S or in T or in both. The intersection get the tuples that are both in S and T, the common tuples actually. And the difference, when we say difference, R minus S for example, we mean that we want the tuples in R but not in S. Okay? The intersection, we write it like this. Okay. The union and the difference are considered as basic operations in relational algebra. However, the intersection is not a basic one because it can be deduced from the basic operations. How? Let's take an example. Assume that we have relation student 1, Ali, 2, Ahmed, and another relation student 2, 3, and 2, Omar and Ahmed. So the intersection between both is this tuple, which is 2 Ahmed. How to get the intersection with another operation? Okay, this is student 1 and student 2. What if we get the difference between student 1 and student 2? In this case, the output will be Ali. So if we make student 1 minus student 2, we will get this tuple as output. Okay? Clear? And next, now we want to get the output of the intersection from another operations. So this one will get us student 1 minus student 2, which is 1 I. Okay, how to get the second tuple or the second row, which is the intersection between both, from another operation other than the intersection? Simply we can make st1 minus all of this. Okay, which means that the whole relation minus this one. So the whole relation minus this one will get us the second tuple, which is 2 Ahmed, which is the intersection between both. So the intersection between two relations can be written as R minus T. That's why the intersection is not a basic operator. Okay, it can be deduced from another operations. At the end, the union intersection difference should be union compatible in order, the relation should be union compatible in order to perform each one from these operations. The product. Let's assume that we have student and course. ID, name, this course, this is student, name of the course, course name, and hours, and can have a foreign key, student ID. Okay, 1, 2, Ali, Ahmed, course name CS, DB, 6 hours, 5 hours, student ID 1, 2, make another row, DB for example, 5 and 1. Okay, when we say product, we mean that we are going to multiply each row in student by each and every row in course. So the first row actually after the product will be 1 Ali CS 6 1, 1 Ali DB 5 2, 1 Ali DB 5 1, and then multiply the second row here by each and every row in course. So it will be 2 Ahmed CS 6 1, 2 DB Ahmed DB 5 2 Ahmed DB 5 1. So the output of the product will have 5 attributes, which is the sum of the attributes here plus the attributes here, and the number of the rows here times the number of the rows here. So here it's 2, here it's 3, so the output will have 6 tuples or 6 rows. Okay, in product the two relations are not necessarily to be union compatible. As we see here, they are not union compatible. However, a product can be done. Okay, now we made a product between these two relations. And now we want to get from this relation the tuple of each student, where each student is enrolled to a certain course. Okay? The connection between the two tables is the ID here and the SID. Okay? So, if we want to know which student is enrolled to which course, after product, we should extract certain rows. Okay? Where the ID is equals to the SID, which is this case, this one, and this one. Okay? In this case, we know that Ali is enrolled to course CS1 because the ID here is equals to here. And Ali is enrolled to course DB because the ID here is equals to here. And here, Ahmed is enrolled to DB because the ID here is equals to here. So after the product, we can select where ID equals to S.ID. Okay? Since the selection after product is common, this is called a conditional join. And we can simply donate it like this. So, selection after product can be written as S join with T under a conditional join, which is C. So this one is equivalent to this one. So in this case, if we want to get the students that are enrolled in a specific course, we can simply write student conditional join T, where the condition is ID equals to SID. Okay? Let's try to solve some examples. Exercise 5.2, we have two relations, instructor and course, where the instructor contain name, office phone, and email. The course contain course number, title, and the instructor name. The attribute instructor name in course references name. So this one is a foreign key for instructor. Write a relational expression to answer the following queries. What is the email address of the instructor and Salah? So we want to get a specific attribute, which is the email address. Okay, so we need to project. Okay, however, do we need to get the email address of all instructors or of a specific instructor? Actually, we want to get the email address of a specific instructor, which is n.salah. So we want to get a certain row or a certain tuple and afterwards get the email from it. So this is simply can be done by selection of name equals to n.salah from instructor. So this part will get us the row where we have an instructor with name n.salah. Do we need the whole row or we need a specific attribute? Actually, we need a specific attribute, which is the email. So we are going to project on this one and get the email. Okay? The next one, B. What are the name of all instructors who do not teach a course? So we want to get the instructors that do not teach any course. We have a table with all instructors and a table of all of the courses, and in this one we have a foreign key which references the name. So here in this relation, in each row we have the name of the instructor that give this course. Okay, so if here we have all instructors and here we have the instructors that teach a certain course. Okay? How can we get the instructors that do not teach any courses? Simply, let's divide this question into parts. Okay? First, how to get the instructors that actually teach a course. The instructors that teach courses will be found in table course. So if we get from here the instructor name from course, this will give us the instructors who teach something. Okay? Clear? Now we want to get the instructors that do not teach any course. All the instructors we have, either they teach or do not teach, are found in this instructor. So if we project on the name in instructor, we will get all the instructors. Either they teach something or not. So now here we have all the instructors. And here we have the instructors who teach courses. So a difference between both will get us the instructors who do not teach course. Because here we have all the instructors, and here we have the instructors that only teach something. So the difference between both will get the instructors who do not teach any course. Since the difference should be union compatible, so we need to check the union compatibility. Actually, the output from here will be a relation of one column name, which is the same type of the instructor name, because instructor name references name. So these are union compatible because this relation has one arity and this has one arity. The type is name and the type here is name as well. Let's move to see what are the name and the office of the database 1 course instructor. We want to get the name and the office of specific instructors. Okay, the name and the office, we can get them from the instructor. However, we want the instructors who teach certain course. So we need something that relate these two relations. How can we relate these two relations? As we have seen in the previous slide, we can simply have a Cartesian product. Okay, so we can have instructor, product, course. But the question is, do we need all the tuples or we care about certain tuples only? Okay, actually we care about certain tuples only where the instructor name is equals to the name. So we can select where name equals to instructor name. Are we done yet? No, because we want specific course, which is the database course. So we want to select the courses with title database. So we can add title equal database. Do we need all the row or certain attributes? We want the name and the office only. So we can project and write name office. This one can be done using conditional join. Let's do it here. The conditional join is the same product with certain conditions. So we can write instructor join course where the name in instructor equals to instructor name, and select title equal DB and then finally project the name and the office. Okay, let's move to another question, which is question number 3. Now consider the relational schema that represents the GUC eBay: seller, item, buyer, stock, purchase. Express the following queries in the relational algebra. Find the IDs of the items purchased for price less than 50 euros and the IDs of the items with a start bid less than 50. Let's divide this query into 2 parts. Let's first get the first part. We want the IDs of item purchased for price less than 50 euros. First, let's search from where we can get this piece of information, from which relation. We want the item ID. We can find the item ID in items, in stock, and in purchase. Okay? So we can get it from any one of this relation. For price less than 50 euros, from where in these 3 relations we have price actually in purchase? So in this case, we are going to get our piece of information from relation purchase, because this one is the one having the price, so we can select the price less than 50 euros. So the first part can simply be done as follows. Select price less than 50 from purchase. Do we want the whole tuple or we want a certain info? Actually, we want the item ID. So we can project on item ID. So here we have output of the item IDs which has a price less than 50, which is the first part of the query. Are we done yet? No, because we want to get the second part, which is the ID of the items with a start bid less than 50. Where can we find the start bid? Here. So in this case, we are going to get our information from this relation, which is stock. So we are going to select start bid less than 50 from stock. Do we need the whole row or we just want the item ID? We want the item ID. So we are going to project item ID. Now we have a relation or output with the item IDs of the purchase less than 50 and the item IDs with the stock less than 50 start bid. Okay? Each of them is independent. However, we want to get the items of IDs of both together because the question states that we want the item IDs of this part and this part. So this is simply can be done using union, because we want the item IDs of this and the item IDs of this one. And these are union compatible because this relation will get one arity, which is the item ID, as well as this one. Okay? Let's move to the second question, which is find the ID of the buyers who either always make a purchase with a purchase quantity less than 5 or haven't made any purchase. Okay. We want the ID of the buyers who either always make a purchase with purchase quantity less than 5 or haven't made any purchase. Now, let's take an example. Assume that we have 2 tables. The buyer. Okay, and we have buyer ID 1, 2, 3, 4, for example. And another table, which is the purchase. Okay, and assume that we have here a buyer ID and the quantity or the purchase quantity. So buyer ID 1, 4, 1, 6, 2, 7, 3, 2. Okay? Apart from the question, let's see which of these rows should be the output in this case. We want the ID of the buyers who either always make a purchase with quantity less than 5 or haven't made any purchase. Which of those buyers haven't made any purchase? Actually, buyer number 4. So, buyer number 4 is part of the output because it or he hasn't made any purchase. Okay? From the other 3, which of these buyers always make a purchase with purchase less than 5? Let's see here. 1 here made a purchase with a quantity 4, which is actually less than 5. So, we should have 1. Let's see here. 1 has made a purchase quantity with 6, which is not less than 5. So, 1 shouldn't be included because it happened once that buyer 1 made a purchase with quantity greater than 5. 2 made a purchase quantity greater than 5. 3 made a purchase quantity less than 5 and haven't made any other purchase with purchase quantity greater than 5. So the output should be 4 and 3. Okay? And we excluded the 1 because it happened that this buyer made a purchase quantity greater than 5. And the question stated that who either always make a purchase quantity less than 5 or haven't made any purchase. Let's see how we are going to express this in relational algebra. Okay? If we, from here, okay, how can we get the buyer IDs who made purchase quantity greater than 5? We can simply select purchase quantity greater than 5 from purchase and product on the buyer ID. This one will return all the buyer IDs who made purchase quantity greater than 5, which is in this case will be 1 and 2. So this one will return 1 and 2. Clear? Now, if we want to get the buyer IDs who do not made any purchase, we simply can write buyer ID from buyers. This one will get us all the buyers in this table, which is in this case 1, 2, 3, 4. The output should be 3, 4, which is actually this one minus this one, because this one gets all the buyers and this one gets the buyers with purchase quantity greater than 5, which is in this case 1 and 2. So the remaining will be 3 and 4, which is the buyers who either made purchase less than 5 or haven't made any purchases. Okay? So number 2 will be projection of buyer ID on buyers minus projection of buyer ID on selection of purchase quantity greater than 5 from purchase. Let's move to the last example, which is the relational schema of hotel, where we have hotel, room, booking, guest. Hotel contains hotel details, hotel number, which is the primary key. Room contains room details, and room number, hotel number forms the primary key together, where the hotel number is the foreign key referencing hotel. Booking contains details of the booking, and the primary key is the hotel number, room number, guest number, and date from, all together. Guest contains the guest details, and guest number is the primary key. Let's check the first question. List the hotel numbers that has rooms with price greater than 150 and other rooms with price equals to 1000. Okay, let's divide this into two parts. We need the hotel numbers where it has rooms with price greater than 150 and actually it has another rooms with price equals to 1000. So there are actually two conditions that should be satisfied to get this hotel number. Okay, let's divide this into two queries. Let's get the hotel numbers that have rooms with price greater than 1500. Okay, so we are going to select price greater than 1500 from room. This one will get all the tuples or the rows of the rooms greater than 1500. Do we care about the whole row or we just care about certain info? We care about the hotel number, so we can project hotel number. This one will get the first part, which is the hotel number that had room with price greater than 1500. Are we done yet? No, because we want the hotel numbers that have rooms with price greater than 1500 and actually another rooms with price equals to 1000. So we need to get the rooms, okay, or the rows with price equals to 1000. We can select price equals to 1000 from room and get the hotel number. We want to get the hotel number that has this type of rooms as well as these types of room. Okay, so how can we relate these two queries? Simply we can intersect. Why? Because the hotel number that has a tuple here and the hotel number that as well has a tuple here will be the one needed, because we want the hotel number that has a room or a type of room greater than 1500 and has another room of 1000. That's why at the end we can get the intersect between them, because we want the hotel number that has rooms with price greater than 5000 and equals to 1000. B. List all the single rooms with a price above 500 per night. So we want the rooms with price above 500 and they should be single rooms, which is the type of the room. Okay? This we can get from relation room. So we can select price greater than 500 and type equal single from row. Do we need the whole row or we just need a certain info from this row? Actually, we want a certain info, which is the room number. So we can project on room number. C. List the name and the address of all guests. From where we can get the info of the guests? From relation guest. In guest we have the name and address. Do we care about all the rows or certain attributes? Actually, we want to get certain attributes from this relation, which is the name and the address. So simply we can project on guest name, address from relation guest. The last one we are going to make today is D. List the price and the type of all rooms at the Conrad Hotel, which is the name of the hotel. We want to get the price and the type of all rooms in a certain hotel. Okay, let's see where shall we get the output of this query. The name of the hotel is found here, so the selection should be done from here. The price and the type is here, so at the end the output will be get from these two relations. Okay, one of the option is a Cartesian product and the other one is the conditional join, as we mentioned before. What is the rows that I'm interested to extract it? I want to get the rows only where the hotel number here is equals to the hotel number. Okay, and the name of the hotel equals to Conrad. These are the rows that I'm interested to extract it after a Cartesian product. So we can make join or product hotel join with room, and the condition is hotel number equals to hotel number. Are we done yet? No, because we want the rows with hotel name Conrad only. So we can select hotel name equals to Conrad. Are we done yet? No, because we want the price and the type. We do not want all other attributes. So we can project price, type from this whole relation. Okay? This one will be the same if we make hotel product room and we put the two conditions outside here. Okay, because the conditional join is equivalent to the product and then selection. Because when we make a product, a lot of redundant and not wanted rows will be generated. Okay, for example, we are going to link rooms to hotels that are not found in this rooms that are not found in these hotels. So we want to extract the useful data only. We want to get the relevant data only, and that's why we select only the rows where the hotel number equals to hotel number, as we did in the student and the course enrolled. Okay, we want to get the tuple where a certain student is enrolled to a certain course. That's why we should select after a product where the student ID here is equals to the student ID here. It's same as what we did here. We want after the product to get the rows where the hotel number in hotel is equals to the hotel number in room. Okay, and since here in the question it stated that we want to get the price and the type of a certain hotel called Conrad, so we selected from this output the rows which has the hotel name Conrad only. Now we have, after this part, we have a list of rows with the hotel name equals to Conrad and all the details of this rows. But we do not want the whole row. We just want to get the price and the type of the room, and that's why After making this query, we projected on the price and the time. That's it for today. And next tutorial, we are going to discuss the other or the remaining operators, which are the natural join, outer join, division, and renaming. Thank you very much, and don't hesitate to contact me if there is any problem. Thank you.